Okay, so let's do a little bit of practice with writing the name from the formula or writing the formula from the name. So this is all mixed together. These are ionic compounds with polyatomic ions, with transition metals, and there are also covalent molecules in here. So when you are asked to name something or to write the formula from the name, oftentimes it's not going to tell you write the name of this covalent molecule or this ionic molecule. It'll just give you the name or the formula and you have to figure it out. So the first thing that you should always do is determine what type of bond it is, because the type of bond is going to determine the rules, the set of rules that you use for naming or writing the formula. Okay, so let's just start up here at the top. So here I have Fe, which I know is iron, and then I have NO3, which I know is one of my polyatomic ions. So this, anything that has a polyatomic ion in it, just from the name ion, that means it's ionic. But also, iron here is a metal. So I have a positively charged metal and a negatively charged polyatomic ion. So this is an ionic bond. So that means we're going to use all the rules for ionic bonds. So there's a few things happening here. First of all, iron is a transition metal, which means we have to include the charge of the ion in the name, because iron can have more than one charged ion. Nitrate, we know, is NO3. I'm just going to write this up here. Nitrate, we know, is NO3 minus 1. And I know that I needed 3 of them to balance this iron. So if this has a charge of -1 and I needed 3 to balance them, this must be iron 3, because I would need 3 positives to balance these 3 negatives. So that means this is iron 3 nitrate. Remember, anytime you have a transition metal, anything that's in this central block here, you have to tell the charge of the ion in the name, because there are multiple. So this is iron 3 nitrate. Okay, so let's look here. This is lead 4 sulfate. So lead is actually Pb on the periodic table, and it is one of the weird exceptions that is a transition metal, even though it's not in this central area. You also know it's a transition metal because they give you the charge of the ion in the name. So again, here's an example of a transition metal, and a polyatomic ion. That means this has to be ionic. It's between a positively charged metal and a negatively charged polyatomic ion. So if I was going to write the formula, it's lead 4. So lead 4 means Pb4 plus. Sulfate is SO4 2 minus. So it's going to be, this is -2, this is +4. I must need 2 of these sulfates to balance out this charge of +4. So it's going to be PbSO4 2. Because this SO4 has a charge of 2 minus, this lead has a charge of 4, so I must need 2 sulfates to balance out that lead. Okay, so let's look at the next one, N2O5. So N2 is nitrogen, O5, just the name N2O5, O is oxygen. These are both nonmetals. Anything between 2 nonmetals is covalent. So remember, the rules for when you're naming something covalent is we don't have ions that we're trying to balance these positive and negative charges, so we use the subscripts and the list of prefixes to tell us what the name is. So I have 2 nitrogens, so it's going to be dinitrogen, 5 oxygens, penta oxide. And you might see it written both ways as either pentaoxide or pentoxide. I believe the most correct rule is that when there is another vowel there, you drop the last vowel of the prefix sound, but you'll see it written both ways. Okay, so let's move on. Ammonium and chloride. Ammonium is one of the polyatomic ions. It's NH4+. It's a positively charged ion with a negatively charged ion, chloride. So this is an ionic compound because it has a polyatomic ion in it. You cannot have polyatomic ions in covalent molecules. So if you see a polyatomic ion, you know it's ionic. Okay, so NH4+ is ammonium. Chloride is in group 7. It wants to gain 1 electron to be like group 8. So chloride is going to be Cl-. So I have NH4 Cl- plus 1 minus 1. I don't need any subscripts. So it's just NH4Cl. So that's ammonium chloride. So now let's look at the next one. Li and then capital I. So Li is lithium. I is iodine. So here is Li and here is iodine. So you should immediately recognize metal, non-metal. That means this is ionic. That means we need to form a bond between the ions. So what are the ions? Well, lithium is going to want to lose an electron. Iodine is going to want to gain an electron. That means it's going to be Li plus 1, I minus 1, plus 1, minus 1. We didn't need any subscripts to balance it, so it's just lithium iodide. Okay, next one, trinitrogen diphosphide. There should be 2 clues here. One is that we're using prefixes. We only use prefixes with covalent molecules. So you know that this is covalent from the tri and the di. But let's look anyways. Let's see where nitrogen and phosphorus are. Nitrogen is a nonmetal. Phosphorus is a nonmetal. Yeah, nitrogen and phosphorus, both nonmetals. So this is covalent. So again, we use the prefixes to tell us how many. Trinitrogen and 3-diphosphide, P2. Okay, let's look at the next one, AgBr. Ag is silver. It's right here. Br is bromine over here. So I know it's between a metal and a nonmetal, so I know this is ionic. Also, check out the location of this silver here. It's in this D block, this middle part of the periodic table. That means this is a transition metal. So this is ionic. And we also have to tell the charge in the name. So I don't know what the charge of silver is here because silver is a transition metal. It can have more than one charge. Bromine, I know, is -1 because it wants to gain 1 electron. So I know this is Br -1, and I know that I didn't need any subscripts to balance it, so this must just have a positive charge, Ag plus 1. So that means that this Ag has a charge of +1, which is important because in the name we have to say silver 1 bromide. If you just say silver bromide, that is not correct. Because silver is a transition metal, you must tell the name, the charge of the ion in the name with Roman numerals. Okay, let's look at the next one. Ammonium phosphate. These are both polyatomic ions. Both of these are on the list of polyatomic ions that I gave you. Here is ammonium, NH4. And here is phosphate, PO4 3-. Do not get phosphate confused with phosphate. phosphide. Phosphide is just P 3-, which is just the ion of phosphorus. Phosphate is PO4 3-. So this is one that people can tend to get confused with. So this is ammonium phosphate. Ammonium is NH4 plus 1. Phosphate is PO4 3-. So remember, this is ionic because it's a positive ion and a negative ion. Remember, ionic compounds have to be charge neutral. Well, the ammonium has a charge of +1. The phosphate has a charge of -3. That means I must need 3 ammoniums for every 1 phosphate. So the way that I would write this is NH4 with parentheses 3 PO4, and you don't put the charge. NH4 parentheses 3 PO4. Okay, let's look at one more. N2F4. So here's N nitrogen, here's F fluorine, and they are both nonmetals, which means this is covalent. I have 2 nitrogens and 4 fluorines. So it's going to be dinitrogen, 4 is tetrafluorine. All right, so that is some practice for naming and writing the formula for ionic and covalent compounds. You will definitely be required to do this in your homework, in the labs, and on the exams.